Imagine a material that never settles. It keeps ticking, not because someone winds it, but because its atoms refuse to stop moving in time. It sounds like magic. It's not. It's a new phase of matter called a time crystal, and it rewrites what we thought was possible. The idea started as a thought experiment. What if a solid could break time the way a magnet breaks rotational symmetry? Instead of forming a repeating pattern in space, it would form a repeating pattern in time. For years, physicists said it was impossible. You can't get something to move forever without energy. That sounded obvious until experiments showed otherwise. In ultra-cold labs and quantum processors, researchers found systems that oscillate with perfect rhythm while the underlying environment stays unchanged. Tap them with a steady beat, and instead of mirroring that beat, they respond at a sub-beat every other pulse forever. The motion is locked in, robust against small disturbances. It's like clapping your hands and having a weird chorus answer you on a delay that never drifts. How does it dodge the laws of physics? It doesn't. A time crystal isn't a perpetual motion machine. The trick is isolation and organization. These systems live far from thermal equilibrium and are often periodically driven. The drive supplies the rhythm, but the crystal spontaneously chooses a slower tempo. Many interacting quantum particles synchronize into a time-locked pattern that resists heating and decoherence. Think of a crowd doing the wave at a stadium. If each person followed the music, the wave would align with the beat. But in a time crystal, the crowd invents its own rhythm and keeps it, even if the DJ keeps the same tempo. That emergent, collective behavior is the whole point. Time symmetry is broken, and a new kind of order emerges. The consequences are stranger than the phrase time crystal suggests. These systems could become ultra-stable quantum memories because their rhythm resists noise. They hint at ways to build more fault-tolerant quantum devices. Some experiments have even twined time crystals with topological effects, suggesting exotic sensors and new information carriers. Beyond tech, there's a philosophical punch. We've always treated time as a backdrop. Now we can make materials that carry time like a property, an internal clock built into matter. That flips how we imagine the boundary between dynamics and structure. This field is young and wild. New flavors keep appearing. Driven crystals, prothermal time order, and hybrid spacetime patterns that look like frozen choreography. Each discovery pushes the boundary between possibility and impossibility. If a chunk of matter can keep its own stubborn beat, what else will we learn to harness? Time as a material sounds like fiction. Today it's an experiment. Tomorrow it could be the backbone of technologies we haven't yet named. If this bent your sense of reality, hit subscribe and join us for more mind-bending science. Share this with someone who loves the future. They'll want to know we just made time behave like a crystal.